Morning students, welcome to the statistics class. In the previous classes or in the previous videos, I was speaking to you regarding interpolation and extrapolation, and I've told you or explained to you how to find the missing values of the dependent variable by binomial expansion method. Two missing values of finding out of the dependent variable by the method which is called as binomial expansion method. So I have given you some problems, and you also have seen the videos related to that. Okay, so there one condition was mentioned clearly, students. The condition regarding when to use this binomial expansion method. The first condition they said is that the values of x, that is nothing but the independent values, should have arithmetic progression. That is the first condition, right? And the value of x to be interpolated, the value of y which is to be interpolated, should be one of the values of x, they said. Should be one of the values of x, they said. Should be one of the values of x. Then only binomial expansion can be find out. Like for example, if x value is 40, and you have to find the value of y when x is 40. That means x is 40, y value is not known, so we have to find out y when x is 40. That is what is you should understand with that statement, that the value of y which is to be interpolated should be the value of x which is in the range. Okay, but now today I'm going to start with the new method which is on the screen, which is called as Newton's advancing difference method, students. Newton's advancing difference method. It clearly you can see here, very clearly you can see that the title is being mentioned for us. Okay, the title is mentioned as Newton's advance here, advancing difference method. Is that clear, students? So I hope it is clear. Okay, so now you understand this, students, that this Newton's method is applicable. This method is applicable in those cases where the independent variable x increases by equal intervals. That is correct. That is, that should be following arithmetic progression, you can say. But the second condition, what is the second condition? Like binomial expansion method, it is not necessary. See the word here, not necessary, that the value of y which is to be interpolated corresponds to one of the given values of x. There in binomial expansion method, it is necessary. But whereas in Newton's advanced difference method, they said it is not necessary that the value of y which is to be interpolated corresponds to the given value of x. So how this can be explained, students? This is what we need to understand. Okay, how we can explain this? You can clearly see here that some values are written here, students. Okay, see this example 1. Now in the binomial distribution, if this value is not given to us, then we can find out the value of y when x is 10. Right, when x is 10. That's what we need. We can find out only those values of y which belongs to those values of x here. This is 1x, this is 1x, this is 1x, this is 1x, this is 1x. If these values corresponding y values are missing, only then we can use binomial expansion method. Okay, so now there is one value here between 10 and 15. The value is something called as 12. Okay, so value of between 10 and 15 of x is 12, students. Now when x is 12, what can be the value of y? What do you say with this? Now question is 12 mentioned in this series here, students? No, it is not mentioned. Is it right? Is it mentioned here? No. 5 is mentioned, 10 is mentioned, 15 is mentioned, but 12 is not mentioned. That is what it means. It is not necessary that the value of y which is to be interpolated corresponds to one of the given values of x. Understand this? For a value of x which is not there in the series, for that value of x, we can find the value of y. This is what is the speciality of this Newton's advancing difference method, students. Okay, right. I hope you are understanding this. Okay, if you have not understood this, you need to go back, rewind it, and once again follow my instructions. Okay, now what is the formula? Newton's formula. This is called as Newton's formula for interpolation, students. This is the formula. Everybody must by heart this formula. Okay, it is given as yx is equal to y naught plus x into delta naught raised to 1, delta naught raised to 1. This is called as delta, students. Delta. This symbol indicates delta. Delta naught raised to 1 plus x into x minus 1 divided by 2 factorial into delta naught raised to 2. This is 1. Next, plus x into x minus 1 into x minus 2 divided by 3 factorial into delta naught raised to 3 plus x into x minus 1 into x minus 2 into x minus 3 divided by 4 factorial into delta naught raised to 4. And it is going on, students, and so on. Now, it should be written up to the number of known values of y. If 5 values of y is known to us, then we have to write delta naught raised to 5. Till there we have to write it. Okay, if n values of y are known, right, if n values of y are known, that's what, if 5 values of y are known, then we can write delta naught raised to 5. Up to delta naught raised to 5, we have to find out, which is called as the nth leading difference. Okay, so this is delta naught raised to 1 is the first leading difference. Delta naught raised to 2 is the second leading difference. Delta naught raised to 3 is the third leading difference. Delta naught raised to 4 is the fourth leading differences, students. That is why this method is called as Newton's advancing difference method. Now, how to calculate that? All these things I will show it to you, and for that we need to form a leading difference table, students. Okay, so now in this y naught we can find out what is that y naught. Y naught we know in that data that will be given when we denote y naught, y1, y2. The first value of y will be y naught. Okay, and deltas, all are, these are leading differences. I said we will see that how to calculate it. Now x. Now to find out x, students, there are two cases that we need to understand. Right? Whenever you come across with a simple set of data, that is raw data x and y, right? Now, if you have to find out the value of y, right, for x is equal to 25, that means the value of x to be interpolated, is 25 here. Okay, for 25, and minus the value of x at the origin. So you can start, you see the x values will be somewhere, will start from 15, right, 20, 25, like that it would be. So what is the value of the start origin? The 15 it is. So the value of x for 25, which is this, to be interpolated, minus 15 divided by the difference between two adjoining values of x. Difference between two adjoining values of x, that is 15 and 20. What is the difference you have? 5. That means 25 minus 15 divided by 5, you get the value of x. If ever the data is given in time series, students, time series, we know what it is, time series. Okay, I just have to show it to you. Okay, in case of what is that? Like we have done the data. We have known this as like this: years, values. This is time series data. Time series like 2001, 2002, 2003, 2004, and the values that here we have like this. This is time series data. So when you come across this time series data and we have to find out the value for 2002.5, right? We have to value for 2002.5, the value of y we have to find out for 2002.5. Then what you should do, the year for of interpolation is 2002.5. This is the year for the interpolation, 2002.5, minus the year at the origin. What is the year at the origin? It is 2001, divided by the difference between two adjoining years. It is only 1. You understanding? Now 2002.5 minus 2001 divided by 1 will get the value of x. So now you need to understand, students, that what is that you are doing it? What is the data that we have it? Is the data which is just x and y raw data? So if x and y raw data, then we have to use this formula. If there is a time series data like this time series data, then we have to use this formula and find the value of x. Okay, the value of x. Now you know what is y naught. Now you know what is x. And now let me explain this to you about the leading differences. So now this is the leading difference table that we need to prepare, students. This is the leading difference table. Okay. So there are 4 leading differences that we need to, since the example is taken for 4 known values of y, 4 known values of y. So there will be 4 leading differences. That is the first difference, this is the second difference, this is the third difference, and this is the fourth difference, students. Okay, this is the fourth difference. Now you should understand how to calculate these differences. So these differences can be done in this way, students. Now first one, let me show it to you this. Okay, that how did they do the first difference here? You can see here they have taken it as y naught, y1 minus y naught, y1 minus y naught. You have understood this? Y1 minus y naught, they have denoted this as delta naught raised to 1. Okay, so right, in the same first difference column, let's see the next one. What is the next one? You see here, okay, y2 minus y1, that is y2 minus y1. y2 minus y1 is delta 1 raised to 1, they have denoted. Likewise, y3 minus y2. Okay, and likewise y4 minus y3, and they have denoted as delta naught raised to 3. Delta 3 raised to 1, sorry. Delta naught raised to 1, 0, 1, 2, 3. And this is all about 1. So we have taken this to be as delta naught raised to 1, delta 1 raised to 1, delta 2 raised to 1, delta 3 raised to 1. Okay, this is the first difference column. Okay, now the second difference, students. The second difference is the differences of the first difference column. Okay, you can see here very clearly here. Delta 1 raised to 1, delta 1 raised to 1 minus delta naught raised to 1. Okay, you can see here this is delta 1 raised to 1 minus delta naught raised to 1. Delta 1 raised to 1 minus delta naught raised to 1 is equal to, they have given us delta naught raised to 2. Raised to 2 is just because of the 2 differences here. Okay, this is the second difference. Likewise, delta 2 raised to 1 minus delta 1 raised to 1. Delta 2 raised to 1 minus delta 1 raised to 1 is equal to delta 1 raised to 2. Likewise, delta 3 raised to 1 minus delta 2 raised to 1 is delta 2 raised to 2. This is the second difference table. Likewise, the third one also is the same, students. The third one also you can find out here. Okay, this is delta 1 raised to 2 minus delta naught raised to 2 is equal to delta naught raised to 3. Delta 2 raised to 2 minus delta 1 raised to 2 is equal to delta 1 raised to 3. Okay, right. Then the last one is this, students. Delta 1 raised to 3 minus delta naught raised to 3 is delta naught raised to 4. So what we see here is, this is one first leading difference. This is the second leading difference value. This is the third leading difference value. This is the fourth leading difference value. These values and the value of x, okay, and the value of x, whenever you substitute in this formula, okay, then with the y naught, substitute all of these values of x and delta naught raised to 1, delta naught raised to 2, and all about y naught. Substituting that, then you get the desired value of y. This is how we calculate the value of y for the value of x, even though the value of x is not in the series. This is how we do the calculation, students. Okay, I will show you how we do it step by step, one problem by problem, students. So this is only just a theory that I have wanted to make you understand, and that is what I have explained it to you, students. So go back and watch this video again to make this concept clear, and you should remember it for a long time. So you need to go back and watch and practice them again and again. In case if you don't understand anything, please call me up or text me. I will explain and I will help you out to understand it better. Okay, thank you, students. Have a nice day.